Hi everyone, welcome back to Geeks for Geeks. In this video, we'll be discussing the problem sum of bit differences. Basically, in this particular problem, we'll be given an array of integers and we'll be having n elements inside it. And we have to find the sum of bit differences for all the pair of elements. Now, what does that mean? So, if you will see, let's say there is any pair x comma y. So what is the bit difference in them? So if you will see, suppose that you have a pair 2 comma 7. So what is the bit representation of 2? So 2 is like 0 1 0. What is the bit representation of 7? 7 is like 1 1 1. So basically, if you will observe, so at two places the difference is there, right? So if I will highlight this point, so you can see that at this place there is a difference, and at this place the bits are different. So basically this would contribute 2 times, right? This will contribute that, okay, the bit difference is 2. And also notice one more thing, that 2 comma 7 and 7 comma 2 will be considered as two distinct pairs. So the sum, inside the sum, 2 will be contributed from here because two places are different here, okay, and 2 will be contributed from the other pair also. So whatever answer you get, you have to multiply it with 2 ultimately, because you have to consider the pair a comma b as well as b comma a. Right, that is one thing that you need to notice. So you have to find this for all possible pairs of the array, right? So basically, suppose that if you have got an array, right? So you have got an array. So in this case, what can you do? If you have got an array and you have to generate all the pairs ai, aj, such that you will find the bit difference for all the pairs from I to j, and you will take the sum of overall of that, right? So in that case, you have to run your I loop from 0 till I is less than n, and then you have to run your j loop from 0 till j is less than n, right? So at least this would take how much time? Even if you are going to generate all the pairs here, then it will take order of n square time at least, where I'm not counting the complexity for bit manipulation as well. So in that case, it is going to take at least n square or more time. So generating all the possible pairs is not a good solution, and that is why this problem was asked in Google, because you need to optimize and you need to think about this problem in terms of bit approach, right? So you need to think in terms of bit. You need to think how you can use the properties of bit in order to solve this problem. So let us quickly see the other test case that is there. So let's say we have a test case that is 1 3 5. Okay, so if we have a test case that is 1, then we have 3, and then we have 5. Okay, so if we have got this particular test case right here with us, then what can we do with this test case? We have to observe. So suppose that we have got 1. So 1 is like what? 1 is like 0 0 1. Okay, then 3 is what? 3 is basically nothing but 0 1 1. Then what is 5? 5 is nothing but what? 1 0 1. So if you find all possible, then it would have taken n square time, because there are 3 elements. But instead of that, we can use the property of bit manipulation here, right? So what I'll do is, for 1, let me just quickly write it as 0 0 and then 1, and then for 3 it is 0 1 1, and then for 5 it is what? It is basically 1 0 1. Now once I have written every number, right, so I will check how many, like I will check how many bits are set in that number and how many bits are not set. So like if you will see here now, so what happens is, for every number that is there, for a particular position you will check. So let's say I will check for the very last position. So let me change the color. So if I check for the position 0th position, okay, so if I check for the 0th position, how you can check if a bit is set or not? You can basically do, if you are at a jth element, suppose, right, and you have to check if the ith bit is set or not. So you can left shift it with I, and you can do an AND with 1. If this value is given as 1, then you can say that ith bit is set in the jth element of the array. Okay, so basically if you will see here, how many ones are there at this place? The number of ones are basically 3, and the number of zeros are basically how much, guys? The number of zeros are basically 0, right? The number of bits that are 1 is 3. The number of bits that are 0 is 0. So 3 into 0, because 3 bits are 1 at this place, and there are no bits that are 0. So you cannot make any pairs here, right? You will not have any bit differentiation. So that's why 3 into 0 will give me 0. That is why it is giving me 0 for this position, because with the help of this position you will not get any bit difference. Okay, now after that, if you move to the next position, so let's move to the next position and see. So if you move to the next position, so moving on to the next position, that is this I is equal to 1th place, right? So I is equal to 1 position. Now if you will see how many zeros and ones are there, so the number of ones are 1. So there is only one set bit at this place, and how many bits are not set, or how many bits are 0? So there are 2 bits that are 0. So basically how many pairs you can make? If you will see, there are 2 bits that are 0, right? And there are 2 numbers which are having bit as 0 at that place, and there is one number that is having bit as 1 at that place. So total number of pairs that you can make is how much? You can make 2 pairs, right, out of it. So that's why it will be like 2 into 1, that is the number of zeros into 1. So that will be 2 into 1, that is nothing but 2 here. Okay, so notice that inside my answer I need to update it as 2 here, right? Because eventually you can see that if I'll be making the pair 1 3, and I'll be making the pair as 3 5, right? So then you will be observing that 1 I can get from here, 1 I will get from here. Why? Because middle position, you can see that at that place both the bits are different, right? For 1 also the bit is 0, for 3 the bit is 1, for 3 the bit is 1, for 5 the bit is 0. So that's why they will add 1 1 each. So overall they will add 2 to the answer, right? I hope that this part is loud and clear. Now coming to the next place, right? So what will happen is, again for the next position you will check. So now for this position you will check the number of zeros are how much? The number of zeros are 2, the number of ones are 1. So how many pairs you will get? You will get like in your answer how much total will get added. So zeros into ones, that is nothing but 2 into 1 is basically 2. So 2 more will get added. So here you can see that the answer will be 4 if you consider only one, like if you consider A comma B pairs only, but you have to consider B comma A pairs also. So whatever answer you get, you have to multiply it with 2 at the end. So you can see that if you multiply 2 to the answer finally, so it will be 8. And for this particular test case, that is the second test case, the answer is coming out to be nothing but 8 here. Okay, now if you will see for this particular position that we had discussed, so what pairs will be there? 1 comma 5 pair will be there, and 3 comma 5 pair will be there, right? So they will add 1 1 each, because for 1 comma 5 you can see that the I is equal to 2 at bit is not set for 1, whereas it is set for 5, and similarly for 3 it is not set, and for 5 it is set. So that's why they will contribute 1 1, and you have to consider 5 comma 1 and 5 comma 3 also. So that's why you have multiplied in your answer. Overall you have multiplied 2 to consider B comma A kind of pairs as well. So finally you return the answer. So what you basically have to do is, you have to iterate for all the positions, and you have to check if ith bit is set in a number, then you will do 1s plus plus. If the ith bit is not set, then you will do 0 plus plus, and answer plus is equal to zeros into ones for that particular position, and you will keep on doing it for all the 32 bits starting from 0 till the 31st last bit. And then after that, once this part is done, then you will simply return the answer. So how much will be the time complexity? If you will see now, so I will be running a loop I starting from 0 till I is less than equal to 31, and then the j loop will be running from 0 till j is less than n, right? And then I'll do a j plus plus. So this will be what? This will be a nested loop whose complexity will be 32 into n, which is nothing but linear in nature. So for our approach, the time complexity would be roughly order of n, and the space complexity would be order of 1. Let's try and code this up now. So I hope that you have understood it clearly. So let us quickly try and write the simplified code of this problem. Okay, so what you will do here is, you will have long, let's say answer initially initialized as 0. Then you will also be starting the loop. So int I starts from where? 0. I is lesser than equal to 31, because the bits are from 0 till 31. Okay, then after that, for every number initially before starting, you will write the number of ones as zeros, and you will also write long the number of zeros as 0. Then what you will do is, you will iterate for every number. For int j starts from 0, j is less than n, then you will do a j plus plus here, and then you will check that if what? If it happens that AR of j left shift I and with 1, so you will check if the ith bit is set, then you need to increase the number of ones. Okay, so you'll do 1s plus plus, else you'll do 0 plus plus. So here you will do 1s plus plus. Otherwise, if this bit is not set, then you will go to the else for this position for the particular number, right? So you will write 0 plus plus. Okay, and then after this, once you have checked for the ith position, then the answer, inside the answer, you will add what? Answer is equal to answer plus the number of ones into zeros as I explained in the dry run, and then at the very end you can simply return your answer here. Now let's try and see if it is working fine on the samples or not. It should work fine. I hope that I have not made any mistakes. So basically, okay, yeah, one more mistake that I already said. I'm counting only a comma b pairs, but since I have to count b comma a also, so I will multiply 2 inside my answer, right? Now let's try and submit this and check if it is getting accepted or not. I hope it should get accepted. The time complexity, as I said, is linear and the space complexity is order of 1. So you can see that our code gets accepted. This problem was previously asked in Google. In case if you have any doubts, you can mention them in the comments. If you have understood this problem clearly, please make sure to comment understood or +1 in the chat, and make sure to like the video as well. Thank you for watching this video, guys, and keep coding.